Welcome back to Nature of Code in Rust and GGEZ. In this video, we're going to update the template to have our vectors. We did that last time in just inside of the example 1.2 project, but now I want to update utilities to have it in here so that when we create new projects or for the new examples or the new exercises, we'll have those. We'll have the vectors available to us. Okay, so I don't actually want to put it just in utilities just like this because map doesn't really feel exactly the way I want it to. I kind of want map separately for us. And what that means to me is I'm going to want to have our utilities in in some kind of a folder, and we're going to have different files for whatever utilities we end up needing. So I'm going to create a new folder here called utilities. And inside of utilities, if I want to pull this in, we're going to need a mod.rs. And inside of lib, now mod utilities, this is fine. It's going to stay exactly as it is right here. And we're going to take this utilities and we're going to move it inside of here, and we're going to rename it to the map. So now we can have map and map, and let's see. Not sure how I want. I think that this works. Maybe I can have like calculations. Probably maybe math. Yeah, it could be okay. We could have the math utilities that have a map function in it. It's a little bit of a tongue twister. So in this mod rs, we're going to export basically and pull in all of these other files together. So we're just gonna have a pub mod for math. And that's it. So now in the main library, we can get utilities. And from utilities, oh, we have nothing that's actually using it here. So let's say I wanted to use it. If I wanted to use utilities, math, and then here's map, and I can then use it. So, should be fairly easy for us. Now, if I wanted to create another one, so pub mod, let's call this like a vector2, it's going to yell at me until I create the file for vector2. Let's do that. We have a vector2. And as soon as I hit save, then that error goes away. So we're going to go ahead and do the exact same thing that we did last time, create the vector structure. Do you want to make this public? Okay, we're going to take in our x and a y of f32s, turn a self. We remember that we want to have that to array. So we're going to have a pub function to array. But before I get too far into this, I want to think about what we need in order to have this be generic. Let's go ahead also implement the add and add assign to, and sort of like think about what that is. Maybe I should have like the to array, and we'll see like what we need to update these to be generic across different number types. So we're gonna have a pub function to array. Okay, so we'll import standard ops add for vector2. Now our type output is equal to a vector2. And we do remember that we need to take our vector2 and we make sure that it derives. Debug is just nice for us to have, but copy and clone are important here. So then we can say, we're going to return a new self with x is self.x plus right-hand side .x, and the y is self.y, that's right-hand side .y. And we're also going to impl add assign. And this is going to be just returning, well, we're not going to return anything here. Just going to say self.x plus equals right-hand side .x, self.y plus equals right-hand side .y. All right, pretty easy and like pretty similar. You know, that is exactly the same as what we had last time, so should be fine for us. All right, so this is yellowness that it's never used. What we can do here is we can say that it's okay that it's not used in the code right now. So we can say allow not used. What is dead code? That's what it is. So we're going to allow dead code. I'm going to copy that line, put you here, and then it won't yell at us. There's no warnings now because we're allowing dead code, at least for these two functions. Okay, now what if we wanted to make this generic? What if we, instead of saying that these were F32s, what if I just said that these were any number? Well, typically we would use a generic, something like a T or a single letter. It can be any, you know, any grouping of letters if we want. But if we do this, then it's going to say there is cannot find type T in this scope. So we need to tell it what that is. Well, we can say that here, I believe. Now this type T is going to be stored in there. So when we impl, we have to also pull in the type T. And oh, I think that's also right here. And then you are type T's. And then down here, okay, impl add for vector2. Now here's a problem, is it needs a type argument for this. Like if I just say type T and try to sort of like do this over again, it now doesn't know what this is. Also, you need to be a type T here. Cannot find, so let's do the impl right here. And everything is so far fine, except look at this error. Cannot add T to T. Consider restricting type parameter T. Okay, so we need to restrict T. So we can do this in many different places. Let's try here. So we're going to say where T implements the trait add. All right, how about you? Expected type parameter T, found associate type T as add output. Consider further restricting this. Okay, so that's not exactly what we wanted here. We need to restrict this further and into something. So there's, and did I make this the right type of add? Oh, it is. Okay. It is the add. Add output. I feel like it needs something else. Now, what I have noticed is there are some typing libraries out there that we can find and that we can use. I don't think I have any that I'm using right here. We could potentially go onto crates.io and try to find one of them really quickly. So I want like number types. This isn't really helping me here. I want number types for restrictions. So basically some like a trait. It's like trait, number, generics. Maybe something will help me there. Here it is, num. A collection of numeric types and traits for Rust. So let's go take a look at this. It's used quite a bit. Usage, well, it doesn't actually show. Okay, so num is a meta crate. It re-exports all these other things. Now, if we take a look at like num integer, this may not be the best place to go find the documentation for it. Let's actually go into the docs. So this returns a big rational type. And we can say that it's a big, and this might work. We can try it. Let's try it. So this is basically num. And from num, we can then pull in all those other types. So we're going to come into our cargo.toml and we're going to add in num. Bring in the latest. Let Rust Analyzer rebuild for us. And here in vector 2, we're going to pull in, we need something. So use num. So there's big int, big rational, bounded, not float. Generic trait for floating point numbers. Okay, let's try num float. So if I do that, now I don't know if I want it to be like float specific right here, but let's say instead of the self output where t is add, I'm going to say, well, you're a float. And then suddenly this starts working. That's because I'm telling Rust that whatever this t is, it has to be a float. Now, behind the scenes, there's a bunch of stuff going on where this is saying, well, actually, we can see this right now, where it's a number, it implements copy, numcast, partial order, negative output equals self. That's what it's really like saying to the compiler behind the scenes. Now, what if I don't want it to only be floating point numbers? What if I want it to be any other type of number? If you're num, well, okay, so you implement partial equal, 0, 1, and numops. The base trait for numeric types covering 0 and 1 values, comparisons, basic numeric operations. So basically anything that's a number sounds perfect for us. So I'm just going to say, hey, you're a num. And then that works. Let's do the exact same thing here. So impl t for vector 2. You're a t, where t implements num. Now, this is a little bit, okay, so cannot use plus equals on type t. We need to further restrict it. So t doesn't help us here, where it did help us up here. Now, I could do equals self.x plus right-hand side x. And I believe it would accept this. It would be happy with this. Let's see, maybe there's like a better num that we can use. Let's try, what else can we find in here? And maybe we should actually go take a look at the documentation itself and find out. So inside of num, Let's see, what else is in here? So we have num, the base trait. There's integer. I don't know if it's integer. I don't think integer covers floats. There's bounded numbers which have upper and lower bounds. Okay. Let's try this bounded here, because like F32s do have upper and lower bounds. Like we can't go beyond whatever the minimum and maximum value is. So if I try bounded, what would we get? So I want you to be bounded. Now okay, so you need to be further restricted. So a number works for the plus, but not for the plus equals. So we just need to find what specific trait it needs in order for it to work with this. Now I wonder if we used integer. Cannot use plus equals on type T. What do you need? I guess like we could also just say add a sign. Like you need to implement add a sign here too. So what if we did that? What if we just say num plus add a sign? Cannot move out of self.x. Okay. So we don't want to move out of self.x. So we want to say like you'd need to like implement copy. You don't implement copy here. So I'm sure that there's a trait, there's like a type in num that would help us like very specifically. I wonder if I can say float. I probably can't say float and integer because it can't be both. So I just say like you're a number plus you implement copy. And here, consider further restricting. Oh, plus add a sign. Then that works here. All right, what are you upset with? Cannot move out of self because does not implement the copy trait. So we need to say here, this T needs to, okay, so where T, we know that this must be a num, and it must implement the copy trait. And so far, this is not unhappy for us. So we don't need these. We don't need this float. Now I'm sure there's a better way of doing this. I'm sure there's like a specific num that like helps us out here. But I wanted to show off that there are these crates that we can use that make generics useful for us. So if we come back to our main library, and we tried to use this, we should be able to now say something like, let's see, what would this be? This is going to be we can create a vector 2 with different types of numbers. So let's just say we have like a let location equals a vector 2. This is going to be our utilities, vector 2, new. And it wants whatever types that we throw it into it. So let's say we do like 1536. And we notice we now have a vector 2 of I32s. Okay, that's pretty cool. We can have a velocity equals utilities, vector 2, new. And we can throw in like a U size, a F32, so we can do like 12 F32, 15 F32, and that also works. Now, location and velocity are not comparable to each other. So I can't actually do like location plus velocity. This won't work because location isn't compatible with the F32 isn't compatible with the I32. And we'll see that here. But I hope that helps explain how generics works. I don't think we're going to be using it very often the rest of this course, but I figured I wanted to like sort of show off what that is, how to use it, and why it could be just a little bit interesting to do. So with that, I'll see you in the next video. Bye.